Sample problem 2307. Figure 23-19A, which is the figure on your right, shows a portion of the two large parallel non-conducting sheets, each with a fixed uniform charge on one side. The magnitude of the surface charge densities are 6.8 times 6.8 microcoulomb per square meter for the positively charged sheet and 4.3 microcoulomb per square meter for negatively charged sheet. So question is, let's find the electric field E to the left of the sheets, between the sheets, and to the right of the sheets. So you have to actually estimate electric field from two plates separately, and then just superimpose those two electric field using that sigma summation. So net electric field will be given by those two electric field at the different area. So let's just estimate electric field out of the positively charged plate first. So that is electric field from positively charged plate is the charge density on that plate divided by 2 epsilon, which is the 6.8 times 10 to the minus 6 coulomb per square meter. And denominator is 2 times 8.85 times 10 to the minus 12 square coulomb per Newton per square meter. So that is same as 3.84 times 10 to the 5 Newton per coulomb from positively charged plate. And what about the negatively charged plate? That produced this amount of electric field based on the same Gauss law, which is the charge density on the surface of that plate by the 2 epsilon. We plug that charge density, which is 4.3 times 10 to the 6 coulomb per square meter, divided by 2 times 8.85 10 to the minus 12 coulomb square coulomb per Newton per square meter. So that's induced the electric field at 2.43 times 10 to the 5 Newton per coulomb. So that amount of electric field is produced by those two plates. So you have to actually just linearly add those electric field to estimate the net electric field at 3 different areas left of the positively charged plate, between those two plates, and the one on the region to the right to the negatively charged the plate. So electric field, as you can see, the positively charged electric field produced the field to the left hand side, and the negatively charged electric field at the region L had field to the right hand side. So they actually, in order to find the net electric field, you have to subtract negative electric field out of the positive electric field. So that should be E plus minus E minus field. So that is 3.4 minus 2.43. Oh, sorry, that's not the number. Okay, so that is same as 3.84 minus 2.43 times 10 to the 5 Newton per coulomb. So that is the here is actually this positively charged, the electric field from positively charged field actually pointing the negative direction in the x-axis, and negatively charged negatively charged plate produced in a field in positive direction. So that should be, this one is E plus, and this one is from E minus from negatively charged field. So if you superimpose them, then that should be minus 1.4 times 10 to the 5 Newton per Coulomb. So that electric field has negative sign, minus sign. It's a magnitude, so it's pointing, that electric field pointing the negative direction on the x-axis. So what about the electric field between those two plates? So the positive charge produce the electric field positive direction, and negative charged plate have electric field inward to the plate. So those two electric field pointing the same direction, so net electric field should be combination, a summation of those two electric field. So that should be E plus E minus. That is 3.84 plus 2.43 and 10 to the 5 Newton per Coulomb, which is 6.3 times 10 to the 5 Newton per Coulomb. And the field right hand side of negatively charged plate is now the field from positively charged plate pointing out, like a positive direction in x-axis, but the field produced by the negatively charged plate is inward to the plate, so that is pointing the negative, x-axis. So you gotta subtract negative field of electric field from the positive electric field. So that is the electric field on the right hand side, and that is E plus minus E minus field. That is 3.84 minus 2.43 times 10 to the 5 Newton per Coulomb. That is 1.4 times 10 to the 5 Newton per Coulomb. So inside the two plate, two electric fields are added together from the two plate, but outside of this, the plate has the same magnitude but in opposite direction. So you have to add negative sign to the field, the right of the positively charged the plate, but the one in the right inside of this negatively charged plate should have the positive the field aligned in the positive direction. So that direction of electric field outside of two plates pretty much depend on the relative quantity of charges on the positive plate or negative plates, and also depending on their distance too. But if those two plates are equally charged with the same amount of charges, then the electric field from those two plates cancel out each other, so they should leave the zero electric field outside of these two plates, only leave double the electric field from one plate inside of these two plates. So there shouldn't be any electric field outside of these two plates, as long as two parallel plates charged with the same quantity of charges. So that is the answer for this example problem.